Okay. So today we're talking about applications of exponential functions, and I think these are kind of neat. Here we go. Example 1. You should write it down. It won't take too long. Example 1. How long will it take? How long will it take? $6,000 to double. How long will it take $6,000 to double if it is invested at 3% compounded monthly? Okay. Compounded monthly. So keyword identifiers here. If something is compounded monthly, do you remember the formula?
One plus
R over T.
R over N.
O to the R.
NT. Okay, gotta write that down.
You wanna make like something I can say like hurt.
A plenert.
It's more like the plenert.
Plenert, yeah.
I think more like
Plenert.
What about
Okay.
key house?
All right. So we want to know what goes where. So what is our initial investment that we're putting into our account? $6,000. That's right. And we want to know what are we interested in when it turns to double. So doubling, we want to know when the amount would reach $12,000 because that would be twice the 6,000 doubling. Okay. What goes in for the R? 0.03. Good. And N. What is N?
Monthly.
12.
N is 12. Yes. So 12 there and a 12 there. And what are they asking us to find?
T.
Yeah, which I always find really weird because they're asking how long. And isn't that kind of not exactly correct? Shouldn't they say how much time will it take? So how long implies length, right? But this, I guess this would be length of time. But, you know, I don't know. Language, right? Okay. So I'm going to plug what I know in. 12,000 equals 6,000 times 1 plus 0.03 over 12 to the 12t. I'm starting, I think, with the hardest problem. Okay.
If this is the hardest, I'm kind of okay.
Okay. So the first thing we want to do, first of all, is this a logarithmic equation or exponential equation?
Exponent.
Exponential, because the x is in the exponent, except it's a t. So the t is in the exponent. All right, so it's exponential, which means if we want to solve this, then we need to isolate our base to the exponent. Isolate the base and the exponent. And it's important you understand here that the base, this whole thing in parentheses is the base of the exponent there. So what do we need to do? Divide by 6,000. And you'll notice what happens when you divide by 6,000. What is 12,000 over 6,000?
2.
As in
The number.
double. Oh, what? All right. So can you imagine what would happen if I had said, find the time it takes for it to triple? What number would you see?
You get like
A 3. Or quadruple, you'd see. Or if I said half. All right. Okay. Half as in half-life. Okay. So No, like the like radioactive decay. Okay. The half-life of a radioactive element. Okay. Okay, now that we've isolated our base and our exponents, I need to do something to drop my power. What's going to allow me to drop my power down?
property.
Ellen
Ellen died.
is a TV host.
Was it
Natural law.
Natural log. Thank you very much. Okay.
Ellen.
It's Latin. So
Yeah.
just like Spanish and French and all those Romance languages, the adjective is after the noun. So like it's logarithm natural. Yeah. Okay. So then this 12t, 12 times t times the natural log of all this stuff. Okay. So now we want to get t by itself. So what do we want to get rid of? We have a lot of stuff we want to get rid of, right? Yeah, we're going to divide by the 12. We're also going to divide by the whole natural log thing. Natural log of 1 plus 0.03. No.
This isn't completely bad.
Okay, and so I think probably the hardest part is just getting this into your calculators, bless you, correctly. So make sure that you put parentheses around this entire denominator. Without those parentheses, it is going to be really, really wrong. So in my calculator, do I have the sweet spot there? Sorry, there you go. There you go.
Just ask.
Oh no,
Okay.
but I'm so stressed out.
Natural log of 2 divided by the whole entire 12. Natural log of 1 plus 0.03 divided by 12. That's the nice thing is you don't need any parentheses in there. Close the set, close the outer set. Lots of parentheses there. And for your Casio, you want to make sure you get those parentheses. Your Casio doesn't put them in. So, all right, so
Hey,
Where's the natural log?
It's the Ellen.
yo, bro, I love queso. Oh, where's this one?
all right, if you did not get 23, then you made a mistake somewhere.
Can I cry?
All right. So make sure. I mean, if you've got a Casio, watch the parentheses because it doesn't add them in automatically. All right. So what does that mean? 23.
23 months. No,
Years. It is years. Yeah. Sorry, what I left out the wording here is 3% and annual interest. Okay.
23 years.
Yeah, 23 years. Long freaking time, right?
Oh, 3%.
Yeah. It's only 3%. That's still more than what savings accounts are earning now.
Really?
Yeah.
That's
Yeah.
possible.
Put your money in the market account. Money market.
What's that?
Like a mutual fund. It's stocks and bonds.
How much do you need to put into mutual bonds? Like,
Yeah, do it. When you're young, definitely put all your extra money into the market. Yeah. All right. Oh, you didn't get it yet? Here. Is that better? A little bit. So you can just put this whole thing in. Okay, let me know if you didn't get your calculator didn't work out for you. All right. All right, I'm ready to move on. Here we go. Example 2. What rate of interest? What are we trying to find?
Hey.
The rate. The rate of the interest. The interest rate. What rate of interest compounded continuously, good, is needed for an investment of $2,000 to grow to $40,000 in 15 years? It's an interesting question. Judging by the last problem, which we just wanted to double our money, and how long did it take? 23 years. And that was at 3%. What do you think this interest rate's going to be? Big.
Research savings interest rate.
So here's what you have control over. Your credit score. So your credit score. So when you guys turn 18, you'll get your first applications for a credit card. Get a credit card, okay? In order to establish credit, you have to have a credit card. If you use a debit card, it does nothing for your credit, okay? So my official recommendation is know exactly how much money you take in and then make all your purchases on your credit card, but never spend more than you make, okay? And just pay off your credit card bill every month. It doesn't cost you any interest when you pay it at the end of the month, okay? It's when you don't pay it off that they charge you the interest, okay? So what your credit score saves you so much money because, for instance, if a normal Joe Schmo were out to get a home loan, then they look at your credit score. And your home loan interest, your interest rate for that home loan is dependent upon your credit score. So a normal person with normal credit, they've missed some payments. They've, had late payments. They've missed payments. They never pay it off. They're always paying the minimum payment. Their interest rate on a home loan might be like 6 or 7%. That is terrible. Because when you think a home loan, you're thinking $100,000 or more, okay? 7% on that is a ton of money, but the worst part is how it's all calculated, which is really, really different. You end up paying, like if your home loan is $100,000, by the end of that loan, you've actually paid more like closer to $300,000 for that house because of the interest. It's horrible, okay? So when you have a really good credit score, like our home loan, our rate on our home loan is like 1.7. It doesn't get low. It's like they give us money away. We go out and buy a new car. Our credit score is so high, 0% interest. It's free money. I'm like, okay, I'll pay off this car in 6 years. So it's not costing me anything extra. So, and that's where having a good credit score really pays off. Okay. We have a perfect credit score. Literally, my husband came in. He's like, "Guess what? I finally achieved my dream." And I was like, 5'6"? He's like, "No." And I have the perfect credit score, and it's huge.
That's okay. That's good.
huge.
My mom's credit score is
Oh,
like 200.
It follows you forever. So. Never ever mess up your credit. Always pay off that credit card bill.
Don't let your identity get stolen.
Oh yeah.
Your credit.
Okay. All right. So this is compounded continuously. So what formula do we use for compounding? Hertz. A equals Hertz. And P times e to the RT. What is e?
Not quite 3.
Not quite 3. Very good. Okay. And so what are we plugging in for the principal? 2,000. And what is A going to be? 40,000. And what else do we know? Time. 15 years. And we are solving for R. We're trying to find R. Okay, so I'm going to plug that in. 40,000 equals 2,000 e to the RT. Oh, t is time is 15. Right. Okay. Again, is this logarithmic or exponential?
Exponential.
Good. And so if it's exponential, then we need to isolate the e to the, we need to isolate this chunk right here. So what do we need to do?
Divide by 2,000.
Divide by 2,000. 40,000 divided by 2,000 is 20. Okay. Equals e to the 15r. And then now what do I do so that I can drop my power?
The natural log.
Natural log. Again, Ellen is a TV show host. And so we get the natural log of 20 equals 15 times R times the natural log of E. Oh, hi, sorry. Thank you. Okay. What is the natural log of E? 1 always, so that's nice. So how do you get R by itself? Divide by 15. Okay. So R equals the natural log of 20 divided by 15. So again, watch your parentheses when you do that. Natural log of 20. Close the parentheses and then divided by 15. Yeah, so this is 19.997. That's interesting. So that that's the R value that we plug in. So what is the actual rate of as a percentage? Yeah. 19.97% APR, annual percentage rate. All right, so I don't know. It's fine. Like remember on my test, you get to look at which choice is closest. So all I say is we save rounding till the very end. So be careful. Don't round until the end. All right, any questions on this one? That one was easier, huh?
Are we done?
No, there's one more.
What happened?
Water.
What?
Oh, it floods in here. What'd you say? Yeah, like
Yeah,
if
it's
you,
actually wet.
Well,
So
Wow, you did.
it's like the wall is wet.
it's actually wet?
Yeah, kind of.
Kind of.
is that new?
Why don't they just seal it up there?
The city's all.
Is it just cold or is it actually wet?
There's like I'm moving around water. Yeah,
Okay.
just a very
That's
small.
good to
cold?
know.
That's not really.
Wait, is it dripping? It's an easy fix.
I know, but
No, it's
The carpet is soaked as well.
Oh, look at that. Yeah, okay. Good. Good to know. Thanks. I will send an email to our engineer.
So
My class was flooded.
You don't want to know what's under this carpet. Okay. Example 3. Okay, so on number 3, they for a certain virus, Q of t equals Q naught e to the negative 0.2 t. I'm gonna write that down. Q of t equals Q naught e to the negative 0.2 t. Yeah, so this is, we say the word not as in nothing. As in like when time is 0. So at the very, very beginning or the initial starting amount, okay? Now what I want you to notice is this any different than our PERT formula? Different letters, but a rose by any other name would smell as sweet, wouldn't it? Oh, look at me getting in some Shakespeare in math class today. Damn, I'm good. Okay. They are the same. Okay. Letters are completely arbitrary. You'll notice we have the E. They both have a base of E. We have a number in place of R. We have the T's, those match. And the difference here is that instead of P, they used a Q sub-0, and instead of A, they used function notation Q of T. They're using Q to stand for quantity. So as in a quantity of virus particles. Okay. How long will it take? Yeah, surely.
I was like, whiz? I was like, I gotta be reading that wrong.
How long will it take 5,000 particles to be reduced to 500 particles?
My mind just auto-corrected it.
Yo, Peter, how long would it take?
How long will it take 500,000 particles to be reduced to 500 particles? So really, they're going to give you the models here, and it's the same thing. It's just different letters. Okay, so what are we putting in our initial quantity?
Oh, that's the initial 5,000.
5,000. We started with 5,000 virus particles. And we want to figure out the time, find the time for us to equal how many? 500. Okay. And you'll notice that the R is negative. And that R is negative because our virus is reducing in size. All right. And so that's we're starting high with our initial amount, and because we're decaying, we'll be decaying to 500 particles.
So does the R just
It does, yeah. It's just notation. It literally just means initial quantity, the starting quantity. What do we want to do first?
give it 5,000.
Good. Divide by 5,000. I hate decimals, so I'm gonna check. Decimals was my first F ever. It is right. Good job. 0.1.
Don't look at me like that, Trinity. I know what
All right. And then what?
you decide on one because you know
Natural log. Very good. So we're gonna, natural log is gonna cause us to drop our power down. So natural log of 0.1 equals negative 0.2 times t times the natural log of e. What is the natural log of e? 1 is the loneliest. Okay, and then how do you get t by itself? Divide by negative 0.2. All right. In your calculator, please make sure you put parentheses around that denominator. All right, so natural log of 0.1 divided by negative 0.2. You actually don't need parentheses, but I'll put them in anyway. What is that?
11.5
11.5. What's our unit here? 11.5 what's? Hours, yeah. Where t is time in hours. So this is 11 and a half hours for the virus to reduce in quantity. So this is probably like, when do viruses actually reduce? When you're on, well, not, I guess a virus you don't get antibiotics for. But let's say in your antibodies are fighting a virus. So if you were to measure that virus in your blood, maybe you get 5,000 particles, and after your body starts fighting it, in 11 and a half hours, there would be a lot fewer virus particles. Does that kind of make sense? Okay. All right, ladies and gentlemen, do you have questions for me? All right. What is number 18?